Okay, so everything is now rewired and the Windows XP is started. As I said, the PC side of things only has to handle two functions. One is to act as a console to my Motorola 68020 board, and the second thing it needs to do is emulate a man-machine interface that ABB produced a long time ago called the Tesselator, which is my man-machine interface for the SCADA system. So the first thing we'll do is we'll fire up the console emulator. In this case I'm using alpha term, and if I make a connection to the board, you can see that we get a boot menu, and the first thing of course I want to do is boot from hard drive. So choose that option and we will hopefully find the SCSI. There we go. And this process will take around about 10 to 15 seconds to boot into the operating system. That's complete. And now we're booting the SCADA system. This will take a little bit longer. We've got a lot more to do here. What we're going to do is load most of the system into primary memory, and that includes the database, the drivers to the graphics system, the drivers for data acquisition, plus any other drivers we need. We're going to load background programs such as alarm event handling, historical logging, etc. And as you can see, as those background processes get loaded, we get the plus numbers coming down the left hand side of the screen, very similar to the way things happen in Linux or Unix. And the most CPU intensive thing we're going to do is load all the calculation tasks, and we've got quite a number running here because it's a demo system. So that took, I don't know, maybe 30 seconds and the system is up and running. Straight away you can see we've got a failure, and that is that we can't connect to the graphics system, and that's not surprising since I haven't started it yet. The SCADA system will look for a valid graphics system. When it finds one, it'll bring it online, and I'll do that in a minute. But before I do that, what I'd like to do is just have a quick look around the 68,000 side of things, and if I log in as super user, and this will give me authority to do anything I like within the OS-9 system. This is similar to root on Unix or Linux. So if we have a look at what background processes are running by typing in the command prox, this will tell me what background processes I loaded, and these were the numbers that were coming down the left hand side of the screen as we were doing the startup. You can see the top few are related to the operating system, like the shell, etc., the prox command that I've just started, and the others are related to the SCADA system. And you can see there's a number of CVUs in there, which are the calculation tasks, and the recover, which is trying to bring the graphics system online. You don't see the database in this list. That is not a process, it's actually a memory module. And if we have a look at what was loaded into memory at startup, these are the programs and modules that were loaded. If I do a more detailed listing, you can see I get all of the information related to every module or program that was loaded. And I won't go through all of these, but if we briefly have a look at some of the main ones, you can see we loaded the kernel, and that is 27,500 bytes. So that's 27.5K for the kernel, very compact and very efficient. And if we look at the database that we loaded, that didn't appear as a process, but it is loaded as a module. You can see the database itself is actually only 17K, and the index to the database is only 78K. So the whole database, which in this system is around about 5,000 objects, only takes up about 100K, so very efficient. The only other command I'm going to run while I'm in the console is the mfree command, and that will have a look at how much RAM I've got available. This was is a 2 megabyte system, and you can see I've got nearly 1 megabyte available for new modules or applications or whatever else. So you can see very compact. I'm not going to labour on the OS-9 side of things anymore. I'll do a little bit more on that in a sister video that I'm doing to this one, which is showing why I'm migrating from one OS-9 version to a newer version so that I can bring this product back to market again. So let's just minimize this terminal, and next we'll start up the Tesselator emulator. I'll do that by clicking on this icon in the system tray. And this emulator was actually produced by my friends at Newcon Data in Sweden. They're ex-ABB people, and basically they were the people that designed the Tesselator in the first place. So because they didn't want me to use this for commercial purposes, they put a splash screen on there, and that's going to stay with us for the duration of the demonstration, unfortunately, but never mind. They did design this thing, so due credit to them. So, as you can see, this has brought up the main menu for the graphics system, and very simple display, just telling me that I'm online and that I've got some options down at the bottom of the screen. Across the bottom, you can see that we've got 12 soft keys, 4 red, 4 green, 4 blue. And if I press any one of the keys that are on the keyboard, if you remember, related to each of these keys, I'll go to that particular display. So let's first off go to the demo display, the first red key, and you will see that that display is now brought up onto the screen. I firstly apologize for the speed of this. It's nothing to do with the Motorola, it's nothing to do with the Tesselator emulator. This is due to the fact that I'm running the screen capture software, and that's slowing everything down on the PC side. However, it won't be this bad all the way through, because the Tesselator has the ability to store pictures in local memory. So once you've been into a picture, it'll store it in memory, and it'll leave it there as long as you it doesn't get overwritten by a new one. So if I go back to the original display, you can see it's far quicker. It's almost instantaneous. The picture comes up, and if I go back to demo, the same thing happens. One key press and it brings it up almost immediately. Another apology is that the Tesselator works with symbols, and I don't have the complete and correct symbol set here. But nevertheless, it's good enough for the purposes of demonstration, and it'll show you, what the functions of the SCADA system are. And if there's enough interest, I'll ask my good friends at Newcon to actually remove the splash banner, and I'll also load the symbol set and clean up any of the displays. So first up, let's go to the display that describes the hardware. Here you can see the original hardware configuration. Again, I say it's quite slow, but again, if I go out and come back in, it's a lot quicker the second time. It just comes up instantly. So the flashing red and yellow system on the left is the hardware solution I'm running on now. One CRT, one Series 20, which is a Motorola 68000 board, and the CRT is actually the Tesselator emulator given by Newcon. You can see that each Series 20 can drive multiple displays. In fact, it can drive 10 operator workstations, and each operator workstation can have up to 3 screens. So actually one Motorola board can drive up to 30 display channels. It can also talk to 25 data acquisition links. These are the things in blue and purple below the flashing red and yellow hardware. And you can assign any protocol to any data acquisition link, and then you can have multiple nodes on that link. The only limitation is that one link can only have one protocol, so all of the nodes must talk the same protocol. Then of course we can network Motorola boards together. In fact, we can have 10 of them together, which means we can have 300 screens and 250 data acquisition links and 2,500 nodes. So very expandable, and all within the capability of a 68,000 in those days. But the other thing that was more interesting maybe is that We could write protocols effectively on the fly. A new protocol would only take us something like 2 weeks, and so if we didn't have the protocol in the library, like nowadays we may be talking about Zigbee, we could write a Zigbee protocol, configure that, and basically add it into the system, and the system would then communicate with a number of Zigbee devices. If we have a look at the software, the way the software works is that we have in the center of the display the database, which I said was loaded into memory, and the database only handles 2 types of object, either analog or digital, and basically we can have any number of object up to the maximum size of 65,000 different entry points. So the database is the heart of things. It's a snapshot of what's happening at any given time, and then we have auxiliary tasks down here in this column, which include historical logging, alarm and event handling and logging, trending, reporting, calculations, batch processes, etc. And of course the user can write his own applications to interact with the database, and we give a full API for that. The data acquisition interface is fully normalized, and we have a number of drivers to PLCs, to computers, to standard devices such as Modbus and various other things. And we basically write a protocol to the device we want to talk to. It comes through that interface and through the standardized data acquisition, and data gets planted in the database. We then have the display subsystem, and this is a thing that handles CRTs, and it's a thing that you can see working now. If you look at some of the graphics that we've got, you can see, if you know some of the way the old systems were built, that they were built as essentially 2 parts. The first was a static part. That's the part of the display that never changes, onto which we overlay the dynamics, and these are the values, effectively graphical values coming from or driven by the database values. And when we add the 2 together, as we can see down at the bottom, you can see that we get the completed display. Or actually it's almost a completed display, because we also have a number of other fields within the display. We have a date and time field across the top. We have an alarm banner at the bottom. This is a thing currently showing a yellow alarm. We have an asterisk here that shows me whether there's a keyboard input or not. If it goes red, we've just received keyboard input. We have the soft keys along the bottom, and the empty field below the alarm event banner. There are 2. The one on the left is a message field from the system, and the one on the right is an input field. So that completes the display. Apart from the actual mimic in the middle, the rest are what we call system fields, and they are the same in every display. So if we have a look at what we can put in terms of statics, this is an old system and it will be updated, but these were the features in the old days. We could have different symbols, which could be alphanumeric or graphic, and we could build them in different sizes. We could have different work areas, such as windows, lines, characters, columns. We could have different writing directions, as you can see down in the bottom right. Different symbols, as you can see down in the middle bottom. And these could be user-built within the system. And we could display everything in different colors. If I look at the dynamic objects that were available to me at the time, you can see that I've got all kinds of different objects, such as numerical fields, and these can be straight numerical fields, or they could be binary fields, or hexadecimal. We can display digitals, either 2 or 4 state, and they could either be text, or symbols, or colors, or combinations of the lot. Or we could have 4-state digitals, which is a combination of 2 2-state digitals. And we can have text, symbols, colors, etc. We can use dynamic flow, and we can use thermometers to show levels in tanks. And the thermometer types we've got are standard up, down, left, right, and horizontal about a center line, and vertical about a center line. We could also show trends on the screen, and we could have up to 12 trend windows displaying up to 16 trends, and these could either be lines like this, or they could be effectively histograms where we filled to a baseline. And the axes we could make dynamic, etc. And we could also have things like bit masks and things, or combination fields for a different object type, including text in one state and numerics in another. If I have a look at how we handle input-output in those days, I've already alluded to this a little bit. We have a mimic which is connected to the real-time database, and here we actually have all the analogs and digitals defined, and that generates what we call an object list in the database, and that object list is mapped to the signal list coming from the device. So we have signal 1 going to value 1, for example. And then within the device itself, in this case the Taylor Mod 30, we actually have the signal defined as an analog or digital. That gets mapped to the signal list in our system. And of course we've got the real process value signals coming in via the physical I/O, via the, in this case, the instrument communications network. In terms of control, the system was fully able to do control, and the way we did this was that we positioned the cursor over an object that was selectable and hit the select key, and that, as you can see, will give me the value down in this area here, currently closed, and with the soft key down here it can change its state to position, so it doesn't really matter which one I change. So I've changed state plus, it will go to open, and if I send, we then select that particular route to that tank. It will try to select the next one, but this value here is closed, and so it can't fill this tank because this value is closed. If we then turn on the process, we do a select, and we change the state and turn it on. We now see that we can use dynamic flow. The valve opens, of course, we can use dynamic flow to see that there's flow in the pipe, and that the level in the tank is going up by the use of the thermometer function. Down at the bottom we're getting new alarms coming in all the time, and that is because we specified this tank to have 2 low limits and 2 high limits, and as we transgress those limits the alarms would be triggered. So demo tank 1, demonstration tank value, and the percentage. Okay, if we go to the alarm list, we can pick up all of the alarms in the system, and you can see a lot of them are related to this particular demo tank. That's because I've just started the process, and you can see the list is in different colors, and we decided that low level alarms would be yellow, red alarms would be the up alarms, and they would be at the higher values. White actually is a trip alarm, so we can actually have 7 types of alarm in the system, and this will display any of the alarms in the system, and of course we can filter. We can filter by priority, there are 32 priorities, and we can filter by process group. We can have up to 32 process groups. There's no limit to the number of alarms in the system, and we can freeze the screen and we can acknowledge. So the format of the alarm is a date, the time, the priority, the group. The asterisk means that it's not been acknowledged yet. We get the reference or the tag reference. The R means it's a repeat alarm. It's been in several times, so we don't clog up the list. Continue to show that. We get the name of the, or an extended name for the value, and then we get a second line of text that gives me more information. For example, test analog 1, short-term problem. We then get the value that made it go into alarm, and the actual engineering units and the alarm that it passed. Here, the low alarm, and it was going negative when it passed that limit. So if we come out of that, we'll go back to our previous display, and you can see that the tank fully filled up in the meantime, and that also went red because it's now fully alarmed. The process is still running, it's still trying to fill the tank, but of course that can't happen. Another feature of the system is that we can have things called super objects, and a super object is basically a combination of simple objects all brought together into a higher level object. An example would be, for example, a PID controller. And that's got a number of signals associated with it, like a measured value, a set point, an output, an auto manual, etc., etc. And you can see a very simplified version of one here. And basically what we can do is we can define a super object that is a regulator. We can tell it what signals make that object up, and we can specify what the individual signals mean. So once we've done that, we can then develop the individual PID controllers, any number of PID controllers within the system. So the interesting thing is that when we've got a display up and we have one value from a super object, let's say the measured value from a PID controller, in this case 765.7, if we select that, we will get a pop-up window that will show us a complete regulator, in other words an object display in a pop-up window. Let's briefly just have a look at a couple of the mimics that we can bring up. Let's have, for example, a steel plant. This was the BOS plant at BSC Ravenscraig. Some of the symbols are not there, but you can see that we can present quite a number of dynamics. Maybe let me pick a better one. Let's go to the water treatment plant. This was one we did for a water treatment plant in Sweden. Bit more complete. It's taking some time to load, again because of the background process of the screen capture. So that took a very long time. But if we exit and we come back in again and we go back to the water, you can see the next time it comes up almost instantaneously. And so we can see the values as bar charts, as analogs. We can see numerical values changing, and we can see flows occurring when indeed that does occur. And these are the kind of process mimics that we could do in the day. Okay, now the next thing I'm going to show you is the maintenance side of the system. Again, if I did this thoroughly, it would probably take the best part of a day. So I'm not going to show you everything. I'm just going to show you a flavor of what we've got. And if anybody's interested, I can send more information and tell you what the newer systems will be doing. So if we look at the 12th soft key, it says maintenance. I can go into that, assuming I've got the authority, and yes I do. And again, it comes up slowly, but basically it gives me a menu of the things I can do within the system. First thing I can do is look at the general system maintenance, and if I just quickly go to that, I can maintain things like users, engineering units, the port definitions, the display definitions, printers, all that kind of stuff, etc. If I want to change things like the alarm and event handling colors, the system-wide colors, I can do that. If I want to modify the database, I can do that, and I will do that in a second. I'll come back to that. If I want to change things like calculation lists, I can do that. I can maintain the logging part of the system, etc., etc. But briefly, let me go to the display maintenance, which is option 7 on this menu. And what this does, it allows me to modify the various components of the display. And again, I won't go through all of these things, but I can change the soft key layout definitions across the bottom. I can change, or I can specify backcloth file directories. I can have any number of directories, and each backcloth file directory can have over 1,000 displays, so we're not limited on the number of displays. I can create or modify a display, which I'll do in a minute. I can duplicate displays. I can look at what displays I've got. I can lock displays into memory for fast update, and I can build hard keys on the keyboard to actually take me to a specific display. And I can go to trends via a specific a trend key on the keyboard. Let me just have a look at number 3. And the first thing that's going to do is go into a menu that asks me what I want to do. And the first thing I'll do is create the display name. We'll call it YouTube. We haven't given it a number, so we give it number, let's say 750, and we'll give it an access mask. and we'll set the first bit. It asks me, we need a display program name. This time we'll call it disprun. Now let's create it again. This time we're successful. Create or modify the backcloth. Now it gives me a blank screen and I can now create a display. So let's just put a pipe, which in my case is just symbols. Okay. Then I might want a valve, and again I'll just choose the correct valve I want. Looks like a valve, but never mind. And we'll continue with the line. And I left it as size 2 so the pipe gets thinner. Okay, so we've created a backcloth. If I want to save it, I can. If I want to create symbols, I can choose a second option. I won't go into that, it's too laborious. I'll just save the diagram, and there you go. I've now got a new backcloth saved in the system. Now what I want to do is put dynamic elements onto that screen, and what I want to do is create dynamics. So I go to option 2, and you can see it will present my backcloth for me, and down at the bottom it gives me some options. The first one is dynamic, and that says go to the next screen or the next set of options to decide on what dynamic element you want to do. I can edit, I can move, I can copy, can delete, can find, etc. Or I can show what is currently dynamics. So I hit the first key, and what it says is what you want. Position the cursor here under the valve, and I say create a numeric field, and it's picked up the cursor coordinates, and I can choose a color by text plus or minus or typing in the value. Let's say cyan. I want a general background color. I want no blink, and we'll call it sign. I think I've got sign in the system. It asks me, do I want the current value? Yes. Do I want a super object? No. What symbol sets do I want? I can have large characters before and small after the decimal point if I want. So here if I say 5-1, I'm going to have size 5 characters before, size 1 after. I then choose the type of field I want, decimal, hexadecimal, integer, etc. and the justification, and then the data shape. This data shape is how it will be presented on the screen. It has nothing to do with the data shape in the database. It's purely for convenience of limiting the size of fields on the screen. So I'll make it 3-2, 3 characters before, 2 after. The display frequency is 1, and we won't have any special fields. Okay, so when I'm happy with that, I say save. And when we go back into the display, you can see I've created my cyan field 3 characters before, 2 after the decimal point, and actually it's in the wrong position. So I position my cursor over it, and I say select, and I then choose the soft key down here that will allow me to move it. So I move the cursor, and I simply say move, and it'll move the dynamic field. I can do the same for all kinds of fields, and the options I've got, as you remember, are dynamics, statics. If I go to the static menu, I can have numeric fields, I can have thermometers, I can have digitals, I can have bit masks, I can have digital controlled elements, I can have flow, I can have text, etc. So that's a very brief indication of how you actually create the display. I'll come out now, and I will go back to my display, which was the menu, if you like, and what I will do, I'll actually put that as a display onto a soft key so that I can call it up. So if I create or modify a display, I'll save the definitions first for the previous one, and then I'll say create or modify, and if you remember, the display was called demo. I'll call retrieve. Yep, that's my correct display. What I want to do now is change the soft key definitions, number 3. And what I've got here is the soft keys for that particular display. And what I'll do, I will actually go to, say, soft key 7. And what we will do is we'll give it a name. I'll tell it what the display name was. So back to the TD menu. And if I exit, ask me if I want to save. Yes, save the keyboard definitions. And I didn't change anything on the backcloth or the dynamics, so that's okay. But I still need to modify YouTube again because I can get into that display but I can't get out. So again, quickly create or modify display. And we go for YouTube. Okay, retrieve it. Yes, that's the correct one. And if I change the soft key definitions for YouTube, I can put that anywhere I want. And the Newcon banner's been a bit of a pain at the moment. So let's just make it on soft key 3. Simply type in exit. Doesn't matter where I am. And it's hash exit to get me out. Sorry, exclamation mark, exit. Okay, and TD menu, exit, yes, save, yes, exit. My finger trouble. So if we then go to the demo system, you now see on the third green key we've got a picture called YouTube. If I select that, you can see that we've got the backcloth, the numeric field updating, and all the rest of it. And we've got the third red key, which will take me out of this display and back to where I was. Okay, so that's displays. But you know, it gives you a feel for what we were doing a number of years ago. And what we need to do, or what I want to do, is bring this up to date using modern hardware and the latest version of OS-9. And in another video, I'll actually show you where we're getting up to on that. Not done very much at the moment, but hopefully it'll show you that we're making some progress. So thank you for watching. I'm sorry it was a long video. I hope you found it either amusing or interesting, and I hope to see you on the next video.